Hey, good evening everybody. Today we'll be looking at Chapter 8, Transfer of Thermal Energy. Basically, in a nutshell, we'll look at how heat is actually transferred from one location to another location. Okay, primarily we'll deal with three methods here, okay, which is conduction, convection, and radiation. Before we look at the mechanism of heat transfer, it's important that we look at why heat is transferred. Okay, or how heat is transferred. Okay, so the how, okay, this is how heat is being transferred. Okay, before we look at it, we'll look at 8.1, okay, the transfer of thermal energy on why heat is being transferred. Okay, let's say you have object A and B, okay, they are being of different temperature, and after some time you observe that both A and B will actually be what we call at thermal equilibrium, which means both of them will be at the same temperature. After a while, we say they cool down or they heat up, but eventually when they are in contact, they will reach a certain temperature, and that temperature is what we call thermal equilibrium. What actually happened is that I would say it's quite common sense that for us to know that actually the hot object will actually cool down, and when the cold object in contact with the hot object, they will actually be heated up. They will actually be absorbing the thermal energy. So when we talk about thermal energy flow, the condition or the main reason behind flow of thermal energy is primarily only one direction. It's primarily from a region of high temperature, and it will transfer to a region of low temperature. So which is why if you look at the direction of transfer, is always from hot to cold. Okay, but this hot to cold doesn't mean it's one-sided. It doesn't mean it is like one time or it just occur at a certain instance. No, even like let's say the transfer is from hot to cold, whereby object A actually loses thermal energy, object B will pick up the thermal energy. But it doesn't mean this will stop or this is a one-time process. The process will actually go bit by bit. The temperature object A, it will actually lose thermal energy and the temperature will drop bit by bit. And eventually when they reaches both the same temperature, it doesn't mean that when they are at thermal equilibrium, the transfer of energy will stop. It will not stop one. Okay. In fact, that the object A and B is always losing energy or gaining energy from other party. For example, A will be losing energy to B, and at the same time, object A could be actually absorbing energy from other surfaces. Object B, same thing. He could be at one instances actually at a slightly temperature higher than object A. He will lose temperature to object B, or maybe he will be absorbing energy from object A, and at the same time he will be losing energy to the surrounding. So which means the energy will be like, let's say from A to B. Object B will actually be losing energy to the environment. Object A might be absorbing energy from the environment. So you'll find that when we talk about thermal equilibrium, when the temperature will actually stays at a certain temperature, but it doesn't mean that the transfer of energy will actually stop. In fact, the transfer of energy will actually be ongoing. Just that the net flow, the overall flow of energy will actually be zero. Which means what I take in, it will be equal to what I given out. But the process of taking in and giving out is actually ongoing one. The only thing that happens when the objects reach thermal equilibrium is that the net flow, okay, between the objects is actually zero. Okay, and that's what we mean by thermal equilibrium, whereby the difference in temperature, okay, is zero, and which means the net flow of the thermal energy between objects will be zero. Okay, but please take note, the word that we are using is net flow. Okay, it's not the flow. Okay, net flow versus the flow. Net flow means, okay, there are multiple flows, multiple transfer, multiple flows. It's just that the input and output is balanced. Okay, that's what I mean by net flow. Okay, so primarily for the whole process, or you look at the three mechanisms whereby you look at conduct, convect, radiation, the heat transfer. Primarily why heat wants to be transferred is primarily because they want to get from a region of hot temperature, high temperature, to a region of cold temperature. And that is primarily the reason why there are different mechanisms to achieve that particular objective. Okay, now let's look at the first mechanism. Okay, the most common or the most basic mechanism that occur in all the three states. Okay, conduction is loosely defined, or is defined as the transfer of energy without the flow of medium, which means in this mechanism, the object actually doesn't move. The physical object, the actual object, actually doesn't move. Okay, does not move. Okay, so with the physical item, the physical object, it doesn't move. What actually moves is actually the energy get transferred from one location. Okay, let's say I heat up a particular rod, okay, from one location, and you'll find that the temperature will be transferred to the other locations. Okay, so then in the process of heat transfer, you'll find that the object, the rod, is actually stationary. Okay, nothing actually moves. So if nothing moves, how does heat get transferred from one end to the other end? Okay, in this case, we will need to look specifically for conduction. There is tagged to the medium, the type of object. We have the first object, which is non-matter. Okay, for non-matter, okay, the primary mode of conduction, how is it being achieved? Okay, is by molecular vibrations. Okay, whereby the particles and molecules, when heated at one corner, the particles will gain energy and they will start to vibrate vigorously. And because they vibrate vigorously, there will be collision. So which means the particle here, when they vibrate, they will collide with the neighboring particles. And when they vibrate and when they collide, the energy will be transferred. And the same cycle will repeat again, which means the particle will vibrate vigorously again, and it will collide into the neighboring particles, and the cycle repeats and repeats and repeats until, okay, heat is being transferred to the other ends. Okay, so in this process of molecular vibration, what actually causes the heat to be transferred is actually transferring of energy between the particles through collisions. Okay, and that is what actually happens in this method 1 of molecular vibration. And this is how conduction actually takes place in where? Non-matter objects. Okay, so if we have non-matter, we will have metal objects. Okay, so what happened for conduction in metal objects? Okay, so take note, there's a distinction between conduction for solid. Okay, so in this case, we are dealing with solid. Solid, primarily, they are metal and non-metal. Okay, non-metal, okay, non-metal here, okay, it includes solid, non-metal. Okay, this method, molecular vibration, also apply for liquid and gas. Okay, so you look at method 1, is actually applies to all medium, solid, liquid, gas. Solid, primarily the mode will be molecular vibrations. But what happened in metal? In metal, molecular vibrations does exist, but it is not the main mode. It's not the primary mode of heat transfer. How conduction is being taking place inside metal objects. What actually happens inside a metal object? Conduction does happen. You heat up one end, the energy get transferred to the other end without the movement of the object. Okay, the thing note, physical object don't move. Heat still the same, it gets transferred from point A, it gets transferred to point B. In this case, you have molecular vibration happening at the background, but what happened is we are looking at the presence of free electrons, because in metals there are a lot of free electrons ongoing inside. So what we have is the same cycle of molecular vibrations will actually take place, but it takes place now within the free electrons. So what actually happens is that when the corner A is being heated up, the electrons will actually be gaining energy. So what is the process now? So when the electrons gain energy, the same thing will happen. They will actually gain energy, okay, and they will actually move at a faster rate now. And because of movement, rapid movements, the same thing will happen. There will be collisions. And now these electrons, when they collide with the particles and other electrons, the same thing will happen. The energy will be transferred to them. And the same cycle will repeat again. The neighboring free electrons, the particles, they will pick up the energy and they will start vibrating and they will start colliding. But what actually is interesting is that this process is actually faster as compared to free electrons diffusion. Okay, what actually happens inside here is actually because the free electrons are actually smaller. Okay, the free electrons are actually smaller, okay, in size and in mass, and because they are smaller, they are able to travel at a faster speed. They are able to travel in between the molecules, the particles inside there, and because of their high speed and because of their smaller size, they are able to travel further and faster. And because of this, collision will actually take place at the further end, and as a result, the transfer of heat energy from one end to the other end by free electrons will actually be much faster if you compare to through the molecular vibrations. Okay, so this is one of the reasons why free electrons diffusion is actually much faster than molecular vibrations. And because of this, you will find that matter actually transfer heat much faster than non-matter. And in fact, it actually transferred the fastest if you look at all the three states. Okay, be it solid, liquid, gas. Okay, now classic example that we have, okay, ice being wrapped around a metal gauze, is boiled, and even if the burner is burned, okay, at this side here, you'll find that the ice at the bottom will actually not melt, or in fact it will actually melt very slowly, even though the flame is heating up and the water actually boils, meaning the temperature is actually very high. Okay, this is a classic example to show that the water is actually a bad conductor, okay, or a poor conductor. Okay, and heat transfer through conductions actually is much slower. Okay, because I get heated up, so by the time the thermal energy get conducted down to the ice to melt, by the time it takes to transfer down, the water at the top, the source, has actually boiled already. So this is a classic example, or this is a good example to show how slow conduction actually takes place in liquid. Okay, and this is actually one of the reasons why conduction is actually one of the common heat transfer method in actually solid. Okay, but do take note, solid, liquid, gas, okay, for conductions, it does occur at all three medium. It's just that the speed is actually different, or to be exact, it's actually fastest in solid, or fastest in matter, slowest in gas. Okay, we will do a summary of the keywords or the concept used in conduction. Okay, now in general, how the questions will actually tend to focus on is on two aspects. One will be on the exact mechanism of how conduction works, which means the marker or the question will actually needs the students to actually explain how conductions in detail, how it works in a particular medium or a particular application or particular objects. So when dealing with this style of question, okay, students will have to actually state whether it's a molecular vibrations as the primary process, or actually it's a free electron diffusion as the primary process. So once you identify the correct processes, the phrasing or the explanation will be the same as the previous two slides. Okay, whereby you explain how molecular vibrations work dealing with molecules collisions, free electron diffusion dealing with electrons collisions. How do we differentiate the main processes? Usually what I will actually encourage students to take note is that it's the medium that's given. For example, if it's free electron diffusion, how do I know free electron diffusion is the main process? Primarily, the medium given has to be solid, and this solid medium has to be a certain criteria, meaning it has to be matter in nature. Okay, because only matter has free electrons, and with that, it allows free electron diffusion to actually take place. As for molecular vibration, that will be even easier. Okay, so it actually, for under solid, okay, the main process, it will actually be solid. It will be actually under non-matter. Okay, so under non-matter, that will be the main process. The main process will be molecular vibrations, followed by liquid and gas. Okay, so liquid and gas, solid for non-matter, the primary process will actually be molecular vibrations. For solid, particularly matter, molecular vibration does exist, but it's just that it will take on a secondary stand. The main process in solid matter will actually be free electron diffusion. So students, you really need to distinguish between the medium being used before you actually select the correct mechanism, and after that follow up with the correct explanations. There is another way of how the question might ask. In the second type of question, it actually deal with the general mechanism, which means that the question will actually deal with needing the students to actually explain how conduction actually take place, okay, in the general form, how heat is being transferred. The exact mechanisms is actually not required. What he actually needs is the overarching idea of how heat is actually being transferred from one end to the other end through conduction. For this type of question, what I actually prepare students to do is actually you need to actually write it in certain keywords. First keyword is actually to tell the marker that you actually understand what conduction is. So you have to actually identify whether the object is actually a good or bad conductor. Okay, so if it's a good conductor, you will conduct at a faster rate. Bad conductor will be actually a slower rate. Okay, so once you identify what type of conductor it is, the second thing that you have to tell the marker is that you actually knows how conduction actually works, and this is actually wrapped up in the second keyword, whereby the students need to tell the marker how heat is actually being transferred to identify which region to which region. So the region that we're talking about is, as I mentioned in the beginning, is from the high region to a region of low temperature region. So the heat transfer is only primarily in one direction, from high temp to low temp, okay, hot to cold. Okay, and in addition to identify the location, the students will need to tag it with the necessary keyword, such as, because it's a process of conduction, it's a conductor, so heat actually is being transferred through a certain mechanism, and that mechanism is actually conduction. So the kids has to say that the heat actually transferred through the conduction, and we usually encourage students to use the words for conduction such as conducts. So the students will actually tell the marker to say that the object actually conducts heat from a high temp region to a low temperature region. So instead of using transfer, general terms like transfer or pass, or maybe heat is moved from one place to another, so we actually encourage students to actually drive down the process to exact mechanism using words like conducts. Okay, so good conductors or bad conductors. So it will conduct heat from high temp region to low temp region. Okay, so as usual, the tagging keyword that we are looking for is, if you are a good conductor, you will actually conduct heat at a faster rate. If you are a bad conductor, you actually conduct heat at a slower rate. So what I actually wrap up, or what I actually package it, is that I actually package it into 3 keywords, whereby first keyword will tell the marker what good or bad conductors. Second keyword and the third keyword actually highlights to the marker how does a good or bad conductors works, or how does it affect the heat transfer, primarily by using words like relating to conductions, okay, which conducts, and relating to heat transfer. Okay, and so these 3 keywords actually give a good representation or presentations to the marker to say that the students actually knows what conduction is and how conduction actually take place in that particular applications. Okay, I hope this will actually give a good wrap up or a good summary of how conduction works in a particular object or a particular medium. And if you have any questions or any comments, okay, any feedback, okay, please leave your comments at the lower section, okay, at the comments area. Feel free to give me your feedbacks or things that I can improve or things that I might need to change. Okay, just leave your comments there. If you need to know get updates on my latest video or latest updates on certain topics, okay, just subscribe to my channel, okay, so that you get those you get the instant notifications whenever I upload videos or I'm conducting a live lesson. Okay, if not, see you.